Okay, small amount of potassium permanganate I will add. What is this? I am going to add in a small amount. Now what is this? Potassium permanganate. And what we call? It is a minor component in this, right? What we call this? Do you remember? Solute. Okay. What we are going to add in a mixture as a minority component, it is called solute. I am going to add in a solvent. Solvent is the major component in a mixture. You can see the color change and composition, how it is uniform throughout the mixture, you can observe. See, potassium permanganate crystals are dissolved in a water, making it a true solution. Now it is considered as a true solution. Okay, beaker A is example for true solution. In beaker B, I have to add colloid. Beaker B is a colloidal solution. So I have taken milk as a colloid here. So beaker C, what I have to take? Chalk powder. I have taken the wheat flour. I have added wheat flour. Here wheat flour is a solute and water is a solvent. First beaker is what? Solution. Second? Colloid. Third? Suspension. Yeah. Can you identify the particles of potassium permanganate in it? Can you able to see particles of potassium permanganate? Can you observe anywhere in here? Below you can observe, at the bottom you can observe, because still that crystal did not dissolve. Okay? After dissolving completely, you cannot observe any particles here, because the size of the particles in the solution is very small. What is the size? Small. What is the size? Small. No?
1 to 10
Less than? Do you remember? Less than
mm.
1 nanometer. Okay? Nano stands for 10 to the power of minus 9. Means very small. The size of the particles in a solution is very small. The last lesson I explained. You forgotten, I think. Okay, the size of the particles in solution is very small. That is in terms of 1 nanometer. Nano means 10 to the power of minus 9 meter. You can imagine how much the size of the particles are. That's why we cannot see the particles in a true solution. That's why we consider true solution as a homogeneous in nature. Okay. So in the next also you can observe in the colloidal solution. Here I think milk contained what we can say. It is not exactly kene antaralla. Adu mix up agirodike at the top layer you can see some particles. But other than that, here also you cannot observe the particles of milk inside the water. So the size of the particles in the colloid is in between. Do you remember? No. 1 nanometer to 10 nanometer. 1000 nanometer. Okay. In the suspensions, the size of the particles will be greater than 1000 nanometer. You can observe the particles of wheat flour. You can see clearly. Right? That's why suspensions are considered as heterogeneous in nature. Colloids also heterogeneous in nature, and suspensions also heterogeneous in nature. You can see spinning, the particles are spinning around. Okay? You can take other examples also. Instead of wheat flour and water, you can take example chalk powder and water, sand and water. Okay? Other examples also you can consider. The next point is about scattering of light. This is actually very important. First difference is about the size of the particles. The first major difference is about the size of the particles. And the next difference is about whether these mixtures scatters light or not. That is the next difference what we have to observe. You can see in the solution, in the true solution you can see, is the path of light visible inside the solution? No, it is reflecting back, right? So the path of the light is not visible, it is nothing but the particles of the solution does not scatter light in a true solution, because the size of the particles are very less enough to scatter the light. Okay, that's the reason the path of the light is not visible. So we say that phenomenon name or that process name is Tyndall effect. We cannot see Tyndall effect in the case of true solution. So Tyndall effect does not see in the solutions. Tyndall effect not seen in the true solutions. Okay. Second, you can see. You can sit. In the second colloidal solution, you observe the path of light is visible. Means the particle size is sufficient enough to scatter the light, because the size of the particles is slightly greater. So it is scattering light. Colloid solution is scattering light. The path of light can be seen in the colloids. So in the colloids we can see the effect of Tyndall. Tyndall effect can be seen in colloids. In the third case, heterogeneous mixture. Is it visible? The path of light is also visible in the heterogeneous mixture. So Tyndall effect can be seen in heterogeneous mixtures also. Okay. So in colloids and suspensions we can see the Tyndall effect, because the path of light is visible. The particles are greater enough to scatter the light. That's the reason Tyndall effect can be seen in suspensions and colloids. Tyndall effect cannot be seen in solutions. This is very important actually.